Number 15, point P, negative 1, 4, lies on line segment QR with endpoints Q1, 7 and R, negative 9, negative 8. Match each ratio of segment lengths to the correct numeric ratio. So what they want us to do is look at these points and find distances between them. Okay, you don't necessarily have to like put a graph on this, but I like to because I want to be able to see what I'm looking at. So I'm going to go ahead and do that. Good little reminder here too of how to graph. So we have negative 1, 4, negative 1, and then 1, 2, 3, 4, and that's P. 1, 7. So 1, and that's 4, 5, 6, 7. I never leave myself enough room. Okay, and then R is negative 9, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's way over here. Again, you don't have to graph it. I like to, because I just want to see like what I'm working with. Okay, so I have P and it's on the line RQ. Okay, I want to know my ratios between R and P, P and Q, and R and Q. So I need to find distances. There's a couple ways you can do this. The distance formula is obviously one of the easiest ways. Or you can kind of make, the right triangle and then use the Pythagorean theorem. Let's do that. I think that's probably one of the easier. I don't know. You can do whichever one you want. Maybe I should do both. But if we make between R and P a right triangle, okay, our length of our base goes from negative 9 into this negative 1. So it's going to be 8 units long. The height goes from negative 8 up to 4. So it's going to be 12 units long. And we can use the Pythagorean theorem. 8 squared plus 12 squared is equal to c squared. Our hypotenuse. 64 plus 144. And then that would give us, I believe, 208. Sorry for the sound. Let's check my math. 64 plus 144. 64 plus 144. 209. No, that's 208. Ah, 208. I hit something wrong that first time. And then taking the square root of both sides, we're going to have the 208, okay? And you hit square root. 14.42 is our C. That is our length, again, of PR, okay? That was that hypotenuse. Now we can do kind of the same thing for the big triangle. The total width going across from negative 9 up to 1 would be a total of 10 units. Your total height goes from negative 8 up to 7, so that would be 15 units. Okay, so now I have 10 squared plus 15 squared equals c squared. 100 plus 225 equals c squared. That's 325. We're going to take the square root of that. Okay, I know I do that fast. It's a video. Go through and pause it if you need to. That gives us 18.03. Okay, and that was the length of the whole thing. That was all the way from R to Q. Okay, so that is our length there. The last length they want us to look at, sorry for the camera. I hope I'm not, giving everybody motion sickness right now. Maybe pause it right here and look at my math if you need to. Now we have to find just between P and Q. So again, This length right here, it goes from -1 to 1, so it's actually 2 units long, okay? The height goes from 4 up to 7, so it's a 3. I'll make it darker so you can see it. 2 squared plus 3 squared equals c squared. 4 plus 9 is c squared, 13. Square root both sides. And the square root of 13, first you type 13, then you hit square root, is going to be 3.61. Okay, and that is our length of PQ. Now, we're looking for ratios. So we want QP to PR. QP, PQ, okay, same thing, interchangeable. 3.61 divided by, because it's a ratio, PR, 14.42. Using our calculator, I keep hitting the wrong button there, 3.61 divided by 14.42 is going to give us 0.25 and some change, right? Well, 0.25 is 1/4, okay? So QP to PR is 1:4, interchangeable ratios and fractions. QP to QR is going to be, QP's up here again, 3.61. QR is this one down here, 18.03. Let's see what the calculator says. 3 point, so you can see it better, 61 divided by 18.03, and we get 0.2 and 2 zeros behind that. So it is basically 0.2. As a fraction, that is 1/5. Okay, so QP to QR is 1/5 right here. And that should be our answers for number 15. As always, if you see me screw up, tell me. Or if there's just an easier way to do this, tell me. I know you could also use the distance formula. So that is definitely on the table there. Leave a comment. Let me know if you think there's an easier way to do it. And I am happy to redo this video if somebody throws something out there a little bit better.